to my house for dinner, it's not unlikely you'd fall right into the middle of a debate. You see, my brother and I dispute or squabble a little too much. I'm vegan and he's paleo. What could go wrong? Through many debates and research trying to prove to him that I am in fact right, I've come across a realization regarding how we look at primary industry production. I'd like to share that with you today. I've lived my whole life in Aotearoa, a paradise of the Pacific, complete with rolling hills, beautiful mountains, friendly locals, and of course, a lot of farms. The dairy industry is a fact of life. It contributes significantly to our economy, with 4.8 million dairy cows in New Zealand, responsible for $13.4 billion worth of exports. With the global population set to rise an additional 2 billion people by 2050, demand for food resources is escalating. World milk production is projected to increase by 177 million tonnes by 2025. But dairying comes at an acutely high price. Potent gases such as methane and nitrous oxide are released from cows. In New Zealand, methane emissions from ruminant animals account for 1/3 of our total greenhouse gas produced. Forget about CO2. Methane traps 84 times more heat over the first 2 decades after release. Temperature rise, ocean acidification, polar melting and species extinction are just a few of the myriad of climate crisis implications. To solve this vast issue, I realised my brother's argument is actually somewhat correct. Dairying is the backbone of our economy, and eradicating it for the sake of the environment is just not going to fly. However, what we can do is propose practical, smaller-scale initiatives to reduce the disastrous impacts of climate change while benefiting our economy. Instead of always thinking big, maybe we need to look down, by our feet, at what's all around us. Yes, grass. Why grass? Well, actually, ryegrass. HME ryegrass holds a key potential to transform New Zealand's dairy industry. HME stands for high metabolizable energy, and this GMO grass is capable of improving animal nutrition whilst also decreasing environmental impacts. Now, even though I've said those 3 controversial letters, GMO, it's really not that frightening. Humans have been manipulating the genome of our crops for millennia through selectively breeding plants with desirable traits. The scientific consensus is that existing GMOs are no more or less risky than conventional crops. Besides, I encourage you to consider that this serendipitous discovery may save the planet. So, how does this magical grass work? To begin, we need to know how it's made, transgenesis. Transgenesis is the process of introducing a gene from one organism to the genome of another. There are 2 genes inserted into ryegrass. The first encodes DGAT1 from nasturtium flowers, and the second is cysteine oleosin derived from sesame. DGAT1 is a metabolic enzyme that is essential for cells to be able to make triglycerides, the way cells store fat. Better triglyceride synthesis means more fat stored, which means more potential energy available to the plant. But for the energy to be available, it needs to be able to be accessed. Cysteine oleosin is a protein that allows triglycerides to be stored in small, accessible packages. Again, greater accessibility means more potential energy available to the plant, which means more plant growth. These 2 genes are normally expressed only in the seeds and pollen, but the cool thing about HME ryegrass is that the scientists have discovered how to turn these genes on in the leaves. All genes are controlled by regulatory elements. These stretches of DNA tell a gene where and when to be expressed, like your alarm clock telling you when to wake up. The scientists at Ag Research use regulatory elements from photosynthetic genes to turn on DGAT1 and cysteine oleosin. This means in HME ryegrass, when light is available, DGAT1 and cysteine oleosin are turned on. This increases triglyceride production and stores it in really accessible packages. This means that it is basically like a packed lunch for the cows. So, what are the benefits of HME ryegrass? There are 3 major benefits: growth, water, and gas. Firstly, growth. Cows eat a lot, and ryegrass is a popular choice of feed for farmers. The HME ryegrass grows up to 50% faster than conventional ryegrass in ag research laboratories and stores more energy for better animal growth. In this image, you can see the comparison between a non-GMO wild type versus HME ryegrass. While grown in identical conditions, the GM grass clearly grows faster, as the lipid levels within the plant are double that of regular ryegrass. You can see this here. This image is a leaf, photographed in a way where you can see the lipid content, the little yellow dots. This increases metabolizable energy up to 8%, improving the overall nutritional value of the plant. For farmers, HME would provide increased yield, i.e. more feed and an improved ratio of energy forms. New Zealand imports 3 million tonnes of feed every year, the majority of which is palm kernel expeller. PKE has a high input cost and in production causes mass deforestation. The growing population requires a 70% increase in overall food production by 2050. So looking towards sustainable, cost-effective feed measures such as HME ryegrass is essential in our development as a country. Secondly, water. The HME plants have shown a 9% increase in water use efficiency, therefore potentially improving drought tolerance due to a slower transpiration rate. These HME plants may also have a more robust root system. With these benefits, HME ryegrass could be a more reliable feed supply for farmers on non-irrigated or drought-prone land. 2/3 of the world's population will live in regions of water stress by 2025. Water is becoming an even more critical resource, and HME may be instrumental in conserving it. But maybe the most exciting benefit of HME forages concerns greenhouse gases. For every 1% increase in lipids within the ryegrass, we can expect a 5% decrease in methane emissions. How does this reduction work? Normally, bacteria and animal rumen produce hydrogen as a byproduct of their metabolism, and this is converted into methane, which the cows belch out. But the plant oil is toxic to the bacteria, therefore methane emissions reduce up to 23%. HME ryegrass could be a game changer in emissions reductions. As described by Dr. William Rolleston, this technology is the best Kiwi science since Ernest Rutherford split the atom. But before we can reap the benefits of this scientific discovery, some specific actions must be taken and stakeholders considered. To get HME ryegrass out of the lab and into our paddocks and cows, we need a review of the law. The current legislation, the HSNO Act, was created in 1996, back when this was top of the charts. How bizarre. It's time for a fresh conversation about biotech crops, GMOs and Aotearoa. Current Prime Ministerial Chief Science Advisor, Juliet Gerard, the Interim Climate Change Committee and the Royal Society all agree this is imperative. What about the issue of gene flow? With approval from the EPA, stewardship protocols would be implemented to minimise any gene flow from the HME ryegrass. Precise testing, including Phil Ralston's studies in Canterbury, have determined that gene flow is limited to within approximately 150 metres, and at this distance it impacts below 1% of plants sampled. Therefore, protocols including a 150 metre buffer zone, controlling flowering dates and managing the reproductive state of a pasture would effectively mitigate what little risk there is in terms of gene flow. Ag Research has been conducting field trials in the United States for over 2 years, modelling the GMO cultivars in real farm conditions. In a recent update, Ag Research's principal scientist, Dr. Greg Bryan, stated, "We have a good understanding of the potential benefits of the grass because of our institutional expertise in animal nutrition and models, as well as from the biochemical analysis of the grasses." This research is still in its early testing stages, but so far, in vitro studies have already shown encouraging results. Conclusive evidence will stem from livestock grazing trials, ideally taking place in our own backyard, to understand if HME really could be a revelation for Kiwi agriculture. Many farmers care very much about the environment, and at present there is enormous uncertainty about the future, which is why HME could be so valuable. Dr. Bruce Thorold of Dairy NZ has said that dairy farmers are looking for new ways to reduce their environmental footprint and improve productivity. The science done by Ag Research to develop these plants is world-leading. And regarding other key groups such as tangata whenua and iwi, built into the HSNO Act is a requirement to consult with tangata whenua. A crucial component is understanding the values in Te Ao Māori, such as kaitiakitanga, guardianship of the land, and how each hapu will have varying perspectives and contexts. Pihia ngā mokupuna. What about the next generations? Māori and Pākehā alike, when surveyed, share a concern for the preservation of our environment for the future. So, here's the bottom line. In order to meet the Paris Agreement targets of limiting global temperature increase to 2 degrees, let alone ambitious goals such as carbon neutral 2050, New Zealand must tackle the gnarly issue of our greenhouse gas emissions from the primary sector. Dairy is a major industry. It's vital. This is what my brother was talking about, and I've since realised just how right he is. If we don't change, we face a loss of competitive advantage to the New Zealand economy that will affect everybody. If Aotearoa intends to increase our dairy production, let's do it in a way that impacts the environment less, that creates fast-growing cows, uses less water, saves money and produces fewer greenhouse gas emissions. Let's do it with HME Ryegrass. After all, mō tātou, a mō ka uri, a muri a kēnei. It is for us and our children after us. Thank you.
Kia ora, Lila.
Kia
Why are you vegan?
I turned vegan when I was 13, mostly for the animal welfare in the first place, and then I realised how beneficial it could be to the environment, so kind of the whole thing.
Now you're encouraging more animals to be farmed.
Well, with our current timelines, it's not realistic to expect that everyone would adopt plant-based diets, though, it could be nice. So I really want it to be possible to people to enjoy dairy while knowing that they would be benefiting the environment as well. Like, imagine sticking a 23% reduction of methane onto a milk bottle. That would sell so much more. So I think it's important to consider that people need to be considering the environment but also enjoying their lives as well.
But the consequences of that, selling more, is in fact more dairy farming. Is that what you want to see?
Yeah, well, not necessarily. Of course, with the growing population, there will need to be an increase in food, a 70% increase by 2050. So it's important to maintain that increase to feed our growing population while doing it sustainably, which is why I'm looking into HME Ryegrass, the benefits that it holds not only for methane but also for growth rate, water use efficiency, even nitrous oxide. It's shown a 6 to 7% reduction in urinary nitrogen load, which could be expected to reduce nitrous oxide emissions and nitrate leaching significantly. So there's some pretty cool implications for it.
My colleague, William Ralston, who I believe is known to you, asks, couldn't we achieve these outcomes with non-GM plants, for example, plantain?
I think that it's important to consider that this issue climate change is the most pressing issue we're going to face, and it's going to take a wide variety of things to come together. I know we're looking into other options such as selective breeding cows to reduce methane with less methane emitters, and then there's an overseas feed supplement called Mutual, and there's also a vaccine that can be used. So I think the collaboration of everything coming together is what is really going to take. So yes, we could look into non-GM plants. GM plants show huge potential for our country, so I think we need to consider those too, definitely.
Thank you.
Thank you.